Fascinating world of chemistry. We're looking again at the atom. Today we're looking at atomic mass identified as value A, which is the number of mass of neutrons, number of protons, mass of the nucleus, the number of protons and number of neutrons. Atomic number, which we identify as Z, which is the number of protons. Now we express atom size in units of the atom, AMU, atomic mass units, or you simply give it the number U. All right? So let's look at a problem here. We got atomic mass of 39, atomic number of 19. How many protons, neutrons, and electrons do I have? Well, I have 19 protons because that's a number, atomic number. And there's no charge here, so the number of protons and number of electrons have to always be the same. To find the number of neutrons, I take the atomic mass, I subtract the atomic number. So I get 20. So I have 19 protons, 20 neutrons, 20 electrons. Copy the rest of these down. We'll do these in class. All right, so we're looking at abundance, means determining the mass based on the average of all the isotope. What's an isotope? Now with the same number of protons, but a different number of neutrons. So let's do an example. A new element was discovered called kelinite, named after the fantastic mathematician, Mr. Kelly. There were 55.95% of the atom atomic mass of 220 U's, 21.98% with 221 U, and 22.07% with atomic mass of 212 U. So what we do to find this, we take the atomic mass of the first isotope, multiply by decimal percentage, and we do the same number for all the other isotopes that exist, and that's giving me the atomic mass. All right, so in this case, we're going to take 220, it's my first atomic mass, and 55.95 is a decimal, we need 0.5595. We then add the other two values, 221 times 0.2198, and 222 times 0.2207. I get 231.1 for sig figs, 4 sig figs, because 220 is an exact number if it's significant. And then we get 48.58 for U and 49.00 for U. We add them all up together. Sig figs, last field column, 200.7 U's. That would be my atomic mass. All right, so we also can try to find the percentage. To calculate the percentage, I can only do it if it's two isotopes. You can't do it if it's more than two because it becomes a complicated mass set, and we're going to leave it at 2. So let's do this one. So we take atomic mass 35, and we don't know what its percentages. We call that X. The other is 36, and we call it 1 minus X because 100% is 1 minus percentage, that's X. Good. And from the periodic chart, we get 35.45 U, and so that's what it equals out. We do the distributive multiply through, so we get 35x plus 36 minus 36x equals 35.453. We're going to combine like terms and get 36 equals minus x. We're now going to subtract 36 from both sides. And minus x is equal to negative 0.547. And then divide both sides by negative 1. X is equal to 0.547, which is what we have for 35. So that means 35U is 54.7%. How do we find the other one then? We'll take 1 minus x, which is 1 minus 0.547, which is 0.453. So 36U is 45.3U. So let's do these other two in class. The abundant atomic mass of the isotope wolframethum. Wolframethum contains 33.5% of 300U, 41.45% for 302U, and 25.00% for 305U. And then determine the percentage composition of two forms of carbon, carbon 12 and carbon 14. We'll do those in class, and then we'll do these afterwards in practice. Hopefully that wasn't too bad. Take care. Be good.